In this video, we're going to look at how to calculate a limiting reagent pH calculation, which is really common in the WACE exam. Like any calculation, there's a series of steps. The first step is we're going to identify the data. We're going to write a balanced ionic equation. Usually, hydrogen ions plus hydroxide ions gives water. We always find the moles of the hydrogen ions and the hydroxide ions. We're going to determine which one is the limiting reagent using the balanced chemical equation. This, of course, becomes the known. We're then going to use the balanced chemical equation to calculate the excess reagent, which will either be the hydrogen ions or hydroxide ions. And then finally, we'll find the concentration, and then we'll find the pH. This will follow a typical stoichiometry flowchart where we're starting with the concentrations of the knowns. And remember, because it's a limiting reagent question, we'll have two knowns. We'll then find the moles of the two knowns. From here, we'll work out the limiting reagent. Once we've got the limiting reagent, we'll find the moles of the unknown, and then we'll find the excess reagent. Then we'll find the concentration of the excess reagent. And finally, we'll find the pH. Now, this will vary depending if we've got excess hydroxide ions or excess hydrogen ions. Now let's look at how to calculate a very simple example. We've got 50 ml of 0.1 molar nitric acid and 20 ml of 0.1 molar sodium hydroxide. We're going to find the pH of the final solution. So this is a typical acid plus base reaction. So the acid provides the hydrogen ions and the base is going to provide the hydroxide ions, and we're going to make water. Now that we've got an equation and we've got the concentrations of two knowns, we're going to find the number of moles using N equals CV. So from the question, we can see 50 ml of 0.1 molar nitric acid reacted. So the number of moles of nitric acid is equal to CV, which is equal to 0.1 times 0.05, which is 0.005 moles. As this is 1-to-1, the number of moles of hydrogen ions is equal to the number of moles of nitric acid, which is 0.005 moles. Now the number of moles of sodium hydroxide is going to be equal to CV, which is equal to 0.1 times 0.02, which is 0.002 moles. Now using the equation, you can see that we have got 0.005 moles of this one and 0.002 moles from this one. So the one that's going to run out first is going to be the hydroxides. So the limiting reagent is the hydroxide ion. Now we've got the moles known, and we've determined the limiting reagent. So now we're going to use our balanced chemical equation to find the moles of the unknown. How much was used up? So as this is a 1-to-1 ratio, the number of moles of hydrogen ions used will equal the number of moles of hydroxides, which in this case will be 0.002 moles. From here, we can find the number of moles of hydrogen ions in excess, which is always equal to the number of moles of hydrogen ions from the start minus the number of moles of hydrogen ions used. So it's 0.005 minus 0.002, which is equal to 0.003 moles. Now that we've got the moles of the excess reagent, what we need to do now is find the concentration of that excess reagent using number of moles divided by volume. So before we can find a concentration, we need to have a total volume, and the volume is 50 ml plus 20 ml. Volumes are additive, so the total volume is equal to 70 ml. And now we can find the concentration of hydrogen ions, which is equal to number of moles divided by volume, which is 0.003 divided by 0.07. And this comes out to be 0.042857 molar. Our final step is to find a pH. Now you need to remember pH is the power of the hydrogen ion concentration. So to find the pH, remember pH is power of hydrogen ion concentration. We use logarithms to find this. So it's negative log of hydrogen ion concentration, which is negative log of 0.042857, and this comes out to 1.37 to 3 significant figures. Now let's try a second example. This time we've got 50 ml of 0.1 molar hydrochloric is added to 20 ml of 0.15 molar barium hydroxide to find the pH. For any calculation, the first step is always to write an equation. And with these sorts of calculations, it's hydrogen ions plus hydroxide ions gives water. Now that we've got our equation, remember we've got two knowns because it's a limiting reagent question, and we're going to find the moles using N equals CV. From there we can find the limiting reagent. So number of moles of hydrochloric, so number of moles of HCl is equal to CV, which is 0.1 times 0.05, which is 0.005 moles. So the number of moles of hydrogen ions is the same. The number of moles of barium hydroxide is also equal to CV. We've got 20 ml of 0.15 molar, which comes out to 0.003 moles. Now you need to watch out here. We need to work with hydroxide ions, and you can see there are two of them. So the number of moles of hydroxides is equal to 2 times the number of moles of barium hydroxide. So this is 2 times 0.003, which is 0.006 moles. Now that we've got our two knowns, we can work out which is the limiting reagent. You can see we've got 0.005 moles of hydrogen ions, and we've got 0.006 moles of hydroxide ions. So you can see the hydrogen ions are going to run out first, so the limiting reagent is the hydrogen ions. Now that we've determined our limiting reagent, we're going to use our balanced chemical equation to find how much is used and the excess reagent. As we now have the limiting reagent, we can now determine how many hydroxide ions have been used. So the number of moles of hydroxide ions will equal the number of moles of hydrogen ions because it is in a 1-to-1 ratio. So the number of moles of hydroxide ions used will be equal to 0.005 moles. So the number of moles of hydroxides in excess will equal the number of moles of hydroxides from the start minus the number of moles of hydroxides used. So this will be equal to 0.006 minus 0.005, which is equal to 0.001 moles. Now that we know our moles of excess reagent, we're going to calculate the concentration of the remaining hydroxide. To do this, we need to know the total volume. So the total volume is equal to 70 ml. So the concentration of the hydroxides is equal to N on V, which is 0.001 divided by 0.07, which comes out to be 0.014287 moles per litre. Now we're at this point where we want to find the pH. Unfortunately, we've got the concentration of hydroxides. And remember, a pH is the power of the hydrogen ion concentration. So we've got two alternatives to get this to this point. We can use either Kw to find the concentration of the hydrogen ions and then do the pH, or we can use a POH and then go 14 minus POH to get the pH. So method 1. Using Kw, we know that Kw is equal to a hydrogen ion concentration by a hydroxide ion concentration. So 10 to the negative 14 would equal the hydrogen ion concentration times 0.01428. So the hydrogen ion concentration equals 10 to the negative 14 divided by 0.01428, which comes out to be 7 by 10 to the negative 13 moles per litre. From here we can find the pH is equal to negative log of hydrogen ion concentration, which is negative log of 7 by 10 to the negative 3, which is equal to 12.2, which is fairly logical because our hydroxides are in excess. Now the alternative method is to find a POH. So we go a POH is equal to negative log of hydroxide ion concentration, which equals negative log of 0.0142857, which comes out to be 1.84. From here we can find a pH, because the pH is always equal to 14 minus the POH, which is equal to 14 minus 1.84, which comes out to be 12.2. You can choose whichever method you want to do. You need to try some yourself. Go to the OneNote Acids and Bases pH and the first set of calculations on it, and there are worked answers on space so that you can check your understanding.